The sun, our life-giving star, can also unleash powerful forces that impact our planet. These forces, often invisible to the naked eye, can have profound effects on our daily lives and the technology we rely on. Solar storms like celestial hurricanes erupt from the sun's surface, sending a barrage of energy and charged particles hurtling through space. These storms are the result of complex magnetic activities on the sun, which can release massive amounts of energy in the form of solar flares and coronal mass ejections. These storms, while invisible to the naked eye, can disrupt our technology and create stunning displays of light in the sky known as auroras. The auroras, or northern and southern lights, are caused by charged particles colliding with Earth's atmosphere, creating beautiful and mesmerizing light shows. Solar storms are a reminder that we live in a dynamic and interconnected solar system. The energy from these storms can affect satellites, power grids, and even the health of astronauts in space. Understanding these connections helps us appreciate the delicate balance of our cosmic neighborhood. While the sun sustains life on Earth, its unpredictable nature requires us to understand and prepare for these powerful events. The sun's activity follows an 11-year cycle, with periods of high and low solar activity, making it crucial to monitor and predict these changes. By studying solar storms and their effects, we can better protect our technology and ensure the resilience of our modern world in the face of the sun's awesome power. Scientists use advanced instruments and satellites to monitor solar activity, providing us with early warnings and helping to mitigate potential impacts on our technological infrastructure. Solar storms originate from intense activity on the sun's surface. Sunspots, which are cooler, darker regions on the sun, are often the starting point. These regions possess strong magnetic fields that can twist and snap, releasing tremendous energy in the form of solar flares and coronal mass ejections, or CMEs. CMEs in particular are the main culprits behind powerful solar storms. These eruptions can launch billions of tons of solar material into space at incredible speeds, reaching Earth in a matter of days. When these charged particles collide with our planet's magnetic field, the effects can be both spectacular and disruptive. Fortunately, Earth is protected from the full brunt of solar storms by its magnetic field, a protective bubble that surrounds our planet. This field acts as a shield, deflecting most of the sun's harmful radiation and charged particles. However, during intense solar storms, some of these particles can penetrate our defenses and interact with our atmosphere. When these charged particles collide with atoms in our atmosphere, they excite the atoms, causing them to release energy in the form of light. This process creates the mesmerizing displays of color known as auroras, which dance across the sky near Earth's poles. Auroras, also known as the northern and southern lights, are a visual testament to the power of solar storms. These ethereal displays of light occur when charged particles from the sun interact with gases in Earth's atmosphere. The colors of the auroras depend on the type of gas being excited. While auroras are a beautiful side effect of solar storms, they also serve as a reminder of the powerful forces at play in our solar system. The same charged particles that create these stunning displays can also pose a threat to our technology and infrastructure. Section 5. The power grid's vulnerability when currents run wild. One of the most significant concerns regarding solar storms is their potential impact on power grids. When charged particles from CMEs interact with Earth's magnetic field, they can induce powerful currents in long conductors, such as power lines. These currents can overload transformers and other grid components, leading to widespread blackouts. The vulnerability of power grids to solar storms highlights our dependence on technology and the interconnectedness of our modern world. A major solar storm could have cascading effects, disrupting communications, transportation, and other essential services. Section 6. The Carrington Event, a solar storm for the ages. In 1859, the most powerful solar storm ever recorded, known as the Carrington Event, struck Earth. This monumental event was named after the British astronomer Richard Carrington, who first observed the solar flare that caused it. The storm unleashed a barrage of charged particles that collided with Earth's magnetosphere, creating a spectacular light show in the sky. This event caused auroras to be visible as far south as Cuba and Hawaii. Normally confined to polar regions, these auroras painted the night sky with vivid colors, mesmerizing people who had never seen such phenomena before. The skies were ablaze with reds, greens, and purples, turning night into an eerie, beautiful day. Telegraph systems, the internet of the time, went haywire, with operators experiencing electric shocks and equipment catching fire. The storm's electromagnetic energy induced currents in telegraph lines, causing widespread disruption. Messages were sent unintentionally, and some operators reported being able to send telegraphs even with their batteries disconnected. The Carrington event serves as a stark reminder of the potential devastation that a powerful solar storm can inflict on our technological infrastructure. It highlights the vulnerability of our modern society, which is even more dependent on technology than in the 19th century. If such an event were to occur today, the consequences would be far more severe, given our reliance on electricity and interconnected systems. Satellites, power grids, and communication networks could be severely damaged, leading to widespread blackouts and disruptions. Preparing for such an event is crucial to mitigate its impact on our daily lives. Section 7. Safeguarding our electric future, shielding against the storm. To mitigate the risks posed by solar storms, scientists and engineers are working on various strategies to protect our power grids and other critical infrastructure. These measures include developing more resilient grid components, implementing early warning systems, and creating procedures for power grid operators to follow during a solar storm. By investing in research, technology, and preparedness, we can strengthen our defenses against the sun's inevitable outbursts. Just as we build seawalls to protect coastal communities from hurricanes, we must take steps to safeguard our electric future from the threat of solar storms. Section 8. Conclusion. Respecting the sun's awesome power. Solar storms are a testament to the awesome power of our sun and the interconnectedness of our solar system. These magnificent displays of nature's force remind us of the sun's dual role as both a life-giver and a potential disruptor. The vibrant auroras, while beautiful, are a visual representation of the sun's immense energy interacting with our planet. While the sun sustains life on Earth, its unpredictable nature demands our respect and vigilance. The sun's powerful rays, which provide warmth and energy, can also pose significant challenges. Solar flares and coronal mass ejections can disrupt communication systems, affect power grids, and even pose risks to astronauts in space. By understanding the science behind solar storms, we can better anticipate their effects and take steps to protect ourselves. Scientists around the world are dedicated to studying these phenomena, using advanced technology to monitor solar activity and predict potential impacts. Their research is crucial in developing strategies to safeguard our infrastructure and daily lives. Through continued research, technological innovation, and international cooperation, we can mitigate the risks posed by these celestial events and ensure the resilience of our modern world in the face of the sun's awesome power. Collaborative efforts among nations are essential in sharing knowledge, resources, and technologies to enhance our preparedness. By embracing a spirit of preparedness and respecting the delicate balance of our planet's relationship with the sun, we can navigate the challenges and opportunities presented by our dynamic solar system. Understanding and respecting this balance is key to thriving in an environment where the sun's influence is ever present and ever changing.